Hello friends, welcome to Learner's Planet. Friends, this is our 9th session for progression and series. In the last session, we discussed good number of problems based on arithmetico-geometrical progression. In this session, we are going to discuss some more problems based on arithmetic geometric progression. So just get ready with your paper and pen. Now this sum the following series to n terms. Here you can see it cannot be broken up into 1 into some other term or maybe 2 into 3, something like that, as we have done in the previous session. So that is this series is something else. Okay, now then also we try to find out some relation. I just write s is equal to 5 plus 7 plus 13 plus 31 plus 85n t n minus 1 plus t n minus 1 term and nth term. Okay, now you can see the difference between these two is 2. Here it is 6, 18, 36. I'm sorry, it is 54. Now you can see the difference is in geometric progression. 2 3s are 6, 6 3s are 18 and 18 3s are 54 and something like that, right? So what we can do is I just rewrite the sequence and just leave the first place. Okay, so it is 5 plus 7 plus 13 plus 31 t n minus 1 plus t n. Now s minus s is 0, then this is 5 plus 7 minus 5 2 plus 6 plus 18, then it is tn minus 1 and minus tn. Now from 5 to tn there are n terms, so from 5 to here there are n terms. Okay, but 5 is not there in this geometric progression, so from this place to this place there will be n minus 1 terms. From 5 to here there will be n terms, but since 5 is not part of this geometric progression, from this to this there will be n minus 1 terms. Okay, so we can take tn this side. Tn is nothing but the nth term, so tn is equal to 5 plus 2 plus 6 plus 18 till n minus 1 term. Okay, now this is a geometric progression with n minus 1 term. Now what will be the sum of this geometric progression? I just write a, that is 2, r raised to n, since there are n minus 1 term I write n minus 1, and here r is 6 by 2, that is 3. R n minus 1 minus 1 upon r minus 1. So r is 3 minus 1, it is 2. Okay, so this is nth term, that is 5 plus 3 raised to n minus 1 minus 1. So that is 3 raised to n minus 1 plus 4. That is the nth term. Okay. Now to find out the sum, we need to do the summation. So sigma, this is 3 raised to n by 3 plus sigma 4 into, we can say 1 or sigma 4. So it is 1 upon 3 sigma 3 raised to n plus 4n, right? 4n times, that means 4n. Now sigma 3n is what? I just show you over here. Sigma 3n, that means 3 raised to 1 plus 3 raised to 2 plus 3 raised to 3 till 3 raised to n. So that is a geometric progression with n terms. So what will be the sum? First term a r raised to n minus 1 upon r minus 1, that is 2. Okay, so this is precisely 1 upon 3 into 3 raised to n minus 1 upon 2 plus 4n. Okay, so 3 raised to n minus 1 by 2 plus 4n. Okay, or you just can simplify it also. So that will be the sum of this sequence. Okay, so when you have to take the summation of a geometric progression, you can do it in this way. Okay. Now here also we have to find out the sum till nth term. Okay, so I just write S is equal to 1 plus 3 plus 6 plus 10 plus 15 and minus 1 term and nth term. Now the difference is 2, 3, 4, 5. Okay, so the next step will be, obviously, I just rewrite the sequence, just leave this place. It is 1 plus 3 plus 6 plus 10 t and minus 1 plus t n. Okay, so s minus s, 0 is equal to 1 plus 2 plus 3 plus 4 plus 5 tn minus 1 minus tn. Okay, now from this to tn there are n terms, so from this to this there are n terms. Okay, and 1 2 3 4 5 all of them are in arithmetic progression. So that's very simple to find out the sum of first n natural numbers. So that is n, I just rewrite tn is equal to, the sum of this series is n plus 1 by 2. Okay, that is the nth term. So sum will be what? It will be, I just rewrite n square by 2 plus n by 2. Okay, so sum will be sigma n square half plus half sigma n. Okay, so that is half n plus 1 2n plus 1 by 6 plus half n plus 1 by 2. Okay, so that is the sum of the sequence. You can take n plus 1 by 2 as common and then simplify this. I hope you are getting it. Now we see this problem. We have to find the sum to n terms of the series 1 upon 1 into 3 plus 1 upon 3 into 5 and so on. So the first thing that we have to do, we have to find out the nth term, right? So here 1 upon 1, 3, 5. The nth term will be 2n minus 1, and 3, 5, 7. The nth term will be 2n plus 1. Okay? So this is a special pattern of question. Okay, now how do we solve this? Here what we have to do, I equate it with a upon 2n minus 1 plus b upon 2n plus 1, right? So whenever you are having this sort of sum, when nothing is, that means in the numerator 1 is there, and in the denominator this sort of numbers are there, 1 into 3, 3 into 5, 5 into 7, something like that, right? So we solve the sums, or we find out the sum in this manner. So 1 upon 2n minus 1 into 2n plus 1, I am just writing it down as a upon 2n minus 1 plus b upon 2n plus 1, right? So here I have to find out the value of a and b. So this expression can be written down as this expressions, combination of this expressions, right? So here it is 2n a plus 2nb minus b upon 2n minus 1 2n plus 1 is equal to 1 upon 2n minus 1 2n plus 1, right? Now we have to equate both the sides. So numerator is equated with the numerator and denominator is equated with the denominator. So in the denominator both the sides are same. So that means 2na plus 2nb minus b is equal to 1. Now on the left hand side the coefficient of n is what? 2a plus 2b, and the constant term is a minus b, and that is 1. In the right hand side coefficient of n is what? 0, because we don't see any terms which is having n. Okay, so coefficient of n is 0. That means 2a plus 2b is equal to 0. That means a plus b is equal to 0. And what is the constant term? Here a minus b is the constant term, and on the right hand side a1 is the constant term. So we can equate it like this. So a minus b is equal to 1. You just see each and every step carefully, because this is some special pattern of question which can be solved by this method only. Okay. I'll be taking one or two more sums with this method. As of now, you just see carefully. Now a plus b is 0 and a minus b is 1. So if you solve, 2a is equal to 1, that means a is equal to 1 by 2 and b is equal to minus 1 by 2. Okay, a is equal to 1 by 2 and b is equal to minus 1 by 2. Now if we put the value of a and b over here, this expression can be converted like this, we can show. Okay, so I just do it. So a is 1 upon 2, 2n minus 1, and b is minus 1 upon 2, 2n plus 1. So this expression can be written as this expression. Okay, now it is easy for us to solve this sort of problems. So just see carefully. Now from here I can take 1 upon 2 as common. So I am left with 1 upon 2n minus 1 minus 1 upon 2n plus 1. Right? Now we are having 1 upon 1 into 3. So 1 into 3. This is n is equal to 1. If we put, we'll be getting 1 into 3. So 1 upon 1 into 3 can be written as 1 upon 2, 1 upon 1 minus 1 upon 3. Right? So 1 upon 1 into 3 can be written as 1 upon 2 outside the bracket 1 minus 1 upon 3. Similarly 1 upon 3 into 5 can be written as, if we take n is equal to 2, it can be written as 1 upon 2 1 upon 3 minus 1 upon 5. Right? So precisely what I am doing, I am just multiplying and dividing the entire expression by 2. So it is 2 upon 1 into 3 plus 2 upon 3 into 5 plus 2 upon 5 into 7 and so on. And outside the bracket 1 upon 2 is there. Okay. Now what? It is 1 upon 2. It can be written as 1 upon 1 minus 1 upon 3. It is 1 upon 3 minus 1 upon 5, 1 upon 5 minus 1 upon 7 and so on. And the last term will be 1 upon 2n minus 1 minus 1 upon 2n plus 1. Right? You can check this expression. 1 upon 1 minus 1 upon 3, it will be 3 minus 1, that is 2 upon 1 into 3. That 2 and this 2 will be cancelled. Okay, if we take all the 2's common. Okay, so this expression can be written as this expression. Now you can see alternate terms are getting cancelled. Like from just the first and the last term will remain there. All the terms will be cancelled. Okay, so precisely we are left with 1 upon 2, 1 minus 1 upon 2n plus 1. Right? So this is half 2n plus 1 minus 1 upon 2n plus 1. Right? So it is 1 and 1 is cancelled. This 2 and this 2 is cancelled. So finally we are left with n upon 2n plus 1 as the sum of this series. Okay? We just go for a quick recap. First of all, we find out the n terms, 1 upon 2n minus 1, 2n plus 1. That can be written as a upon 2n minus 1 plus b upon 2n plus 1. So this way we can find out the nth term. So nth term will be equal to, then you have to equate. So you get the value of a and b, that is 1 upon 2. A is 1 upon 2 and b is minus 1 upon 2. So this expression 1 upon 2n minus 1 upon 2 into 2n plus 1 can be written as like this. Okay, so if we take 1 upon 2 as common, any term can be written as 1 upon 2n minus 1 minus 1 upon 2n plus 1. So if you put n is equal to 1, you will be able to get 1 upon 1 into 3. If you put n is equal to 2, you will be able to get 1 upon 3 into 5. So this expression can be written as this expression. After that, all the terms will be cancelled. You can see it's minus 1 by 3 plus 1 by 3 minus 1 by 5 plus 1 by 5 and so on. Right? So 1 minus 1 upon 2n plus 1 is left. So if you solve, you'll be able to get n upon 2n plus 1 as the sum of the series. So this is going to be important. I do just one more sum like this, I'm sure you'll be able to understand it. Now this is the similar sum. Here nth term is already given, so what I do, I write 1 upon 5n minus 4 into 5n plus 1 is equal to a upon 5n minus 4 plus b upon 5n plus 1, right? So 5na plus 5 plus a plus 5nb minus 4b is equal to 1, because denominators will get cancelled if we equate. So what is the coefficient of n on the left hand side? It is 5a plus 5b. So 5a plus 5b is equal to 0, or we can say a plus b is equal to 0. Then the other relation we have is the constant term a minus 4b. So a minus 4b is equal to 1 and a plus b is equal to 0. So if you deduct this from this, you'll be able to get the answer of the values of a and b. So a plus minus, it is 0. So minus 5b is equal to 1. So b is equal to minus 1 by 5, right? And a plus b is equal to 0. That means a is equal to 1 by 5. So we got the value of a and b. So each and every expression can be written as 1 upon 5, 5n minus 4 plus 1 minus 1 upon 5, 5n plus 1. Okay. So 1 upon 1, I just write down first of all 1 upon 5, 5n minus 4 minus 1 upon 5, 5n plus 1. Right? Now you put n is equal to 1, you'll be able to get 1 upon 1 into 6, and that can be written as like this. Okay? So precisely what is happening, if you put n is equal to 1, 1 upon 5, this is 1 minus 1 upon 5, this is 6. Okay? So what it is? 1 upon 5, 1 upon 1 minus 1 upon 6. Okay. So what we are doing, will be multiplying the numerator and denominator by 5. Okay. So it is 1 upon 5, it is 5 upon 1 into 6 plus 5 upon 6 into 11 plus 5 upon 11 into 16 and 5 upon 5n minus 4 into 5n plus 1. Right? Now 5 upon 1 into 6. So that can be written as 1 upon 1 minus 1 upon 6 plus 1 upon 6 minus 1 upon 11 plus 1 upon 11 minus 1 upon 16 plus 1 upon 5n minus 4 minus 1 upon 5n plus 1. Right? So this is cancelled. So we are left with 1 minus 1 upon 5n plus 1. Okay, so this is 5n plus 1 minus 1. So that is 5n upon 5 into 5n plus 1. So 5 and 5 is cancelled. So we are left with n upon 5n plus 1. That is the sum of this series. Okay. And for your quick reference, I would like to share a short trick over here. See, when you see a sequence that is consecutive numbers 1, 6, 6, 11, 11, 16, 16, 23, right? You can see the second number is first number over here, second number is first number over here. Then what you can do directly, if you want, you can come to know that there is a difference between these two terms is 5, right? So multiply and divide the entire sequence by 5. Ultimately you are getting 5 over here. That's 1 by 5 and this is 5, right? So you can directly come to know what is the number that you are going to use for multiplication and division, right? That is the nothing but the number 5 over here, what that is the difference between these two. In the previous case also you did the same thing. I just show we multiplied and divide by 2, that is the difference between these two. Okay, so that's a short trick that you can use for your verification, right, whether you are doing correctly or not. So friends, I hope you might have enjoyed the session. In the next session we'll be discussing more problems. Do revise this session in the previous ones. Bye bye.